Hello friends, today we are going to learn joints in cement concrete pavement or rigid pavement. So joints are the weakest link in the concrete pavement, but it is also necessary evil. Generally, all the deterioration of a cement concrete is in the vicinity of the joint, and hence these are planned and constructed with a due care. Joints are necessary in the cement concrete due to the following reasons. There are many reasons why these have to be provided. You just listen carefully. This allows the cement concrete slab to expand and contract under the action of temperature moisture change, thus relieving the warping stresses due to the temperature. This allows the pavement to be laid in bays in lanes and convenient width. This allows suitable measures for braking at the end of the day work. As far as possible, the number of joints should be kept minimum, since laying of joint interferes with the progress of the concreting and riding quality of a road is reduced if the joints are more in number. A good joint should have should have many characteristics, like it should be waterproof and should not allow dirt or stone grit to enter it. It should be freely available. Free movement should be available at the joints. It should not cause unnecessary hindrance to the concreting operation and should not be very weak so as to pose very structural weakness, and also it should not hamper the riding quality of the road to significant extent. Now there are several types of cement concrete joints. Basically these are classified into two types, that is longitudinal joint and a transverse joint. So coming to longitudinal joints, in cement concrete pavement the width is 4.5 meter. There is a need to provide the longitudinal joint. See, now the figure is showing you the two cement concrete slabs are casted and in between some space is left. This is nothing but a longitudinal joint. This helps for the easy expansion and contraction purpose. The need of this longitudinal joint is to prevent the shrinkage crash happening during the initial period of the curing. However, as the length of the width is generally 3.5 to 3.75 meter, longitudinal joints provided between each traffic lane. Shrinkage cracks develop in the slab whose width or length is more than 4.5 meter. If suppose this is a cross section of a longitudinal joint, the tie bars are provided along the longitudinal joints in order to prevent the opening up of this longitudinal joint in due course. These tie bars of specific diameter and length are embedded at the specified spacing at the mid depth of the pavement slab. As in the previous figure we have seen how these tie bars are provided to keep these longitudinal joints intact. Functions of this longitudinal joint: firstly, contraction joints and prevents the development of additional shrinkage cracks in the longitudinal direction. Then warping joints and relieve part of a warping stresses, means it will help to relieve maintain the surface from being cracked. It will help to reduce the warping stresses, and lane marking in highways can be 2 or more in lanes. Now second type is the transverse joints. Now in this transverse joints, these are subdivided into various categories as expansion joint, contraction joint, warping joints, and one more there is a construction joint. Here warping joint is not written, you add it in this. So firstly, let us see the simple one, that is a construction joint. Simply you can remember this provides the room for the contraction of the concrete slab that might occur due to the change in the temperature. The tensile stresses are thus relieved and warps are reduced. The width of the groove should not be less than 3 meter. See the figure correctly. Depth of the groove should be 25 to 30% of the pavement thickness. Spacing of the two contraction joints should be 4 to 5 meter. The shrinkage crack formed below each groove at the weakened section during the initial period of the cracking. Anyhow, the shrinkage cracks formed at the regular interval to prevent those cracks, contraction joints are provided. Okay, so this is the figure which will show you closely spaced contraction joint helps to relieve the part of a warping stress which may be developed, and if no reinforcement is provided across the contraction joint, such a pavement is pain joint construction pavement. Next is the expansion joint. Expansion. These joints provide the room for the expansion of the pavement. The compressive stresses that might be generated because of the prevention of the expansion are thus reduced, and bulking of a cement concrete is avoided, generally provided at 18 to 20 meter of interval. Okay, these are generally, see the figure, these are generally provided at interval of 18 to 20 meter, and these are provided in full width of and thickness of the slab. Okay, the expansion joints are provided in number of contraction joints. The cement concrete pavement slab is separated across the expansion joint, therefore there is no load transfer across the expansion joint. See the figure. The figure is self-explanatory figure. These are weak cross section of a cement concrete pavement. In order to strengthen this section and to provide load transfer across the expansion joint, suitable dowel bars are designed and installed during the construction. Next is the construction joint. Construction joints formed due to the gaps between the continuous construction process. The transverse joint constructed when the construction work of a road slab is to be ended at a place where other specified joint due to any reason is called as a construction joint. Means from the next day you can start from that particular area. Construction joint form across the pavement and full depth. It is necessary to provide dowel bar across these joints for the load transfer. Okay, see the figure. Today if you want to stop here, that point is called as a construction joint. So from next point again you can start from that particular point. Now what are the factors affecting the rigid pavement? There are several factors which are affecting the design and performance of a rigid pavement, or we can say the cement concrete pavement, like wheel load, temperature variation, type of joint. Okay, so the two major factors preliminary to be considered for the design of rigid pavement are heavy traffic loads and temperature variation at top and bottom. The other factors which affect the design and performance of a rigid pavement are temperature stresses, then volumetric changes in subgrade, and loss of subgrade support due to the any other reasons. So let us learn all these factors one by one in detail. So firstly, wheel load. So how the wheel load is going to affect the cement concrete layer. So the performance of the rigid pavement and its service life depends upon the actual magnitude of a heaviest wheel load of the wheels and the number of repetitions during the design life. The wheel load of the highest magnitude causes the flexural strength in the rigid pavement. The important factor associated with the wheel load are magnitude of wheel load, pressure of the loaded area, location of the loading of a cement concrete area, repetition of the load during the entire design life. Magnitude of the load. The magnitude of the wheel load is directly affecting the stresses in cement concrete pavement. Higher the magnitude of the wheel load will cause higher stress in pavement. The wheel load is expressed in terms of the following. Suppose P is the total load in kg. Small p is the contact pressure in kg per centimeter square. Contact area is denoted by A in centimeter square, which will be equal to pi A square into P, where A is a radius of equivalent circular area in contact. Assume that the wheel load act on a circular area of contact. Now where will be the location of this load application on the slab? The wheel will be circular. So exactly where it will be in contact. The load stresses on the slab are varied depending upon the location on which the wheel loads are acting. Following three locations are considered in the analysis and design of cement concrete pavement: interior, corner and edges. Okay, so the magnitude of stress due to a given wheel load applied at the corner region is highest in comparison to the stresses due to the same load applied at the edges or interior region of a cement concrete pavement. You can see that this is a common thing, that the magnitude of stress due to the any load applied at the corner region is much higher in compared to the stresses that will be same load applied at the edge or interior of a cement concrete pavement. The load stress applied at the interior region of a cement concrete pavement away from the edge is found to be lowest in comparison to the stress to some load in the edges or an interior region of a cement concrete pavement. Repetition of the loads. What will be the effect of repetition of the loads? The repeated application of a high light loads do not cause any structural deterioration to the road. Therefore, it is essential to measure the loads of a high magnitude which could cause significant stress levels in the rigid pavement. For design of a rigid pavement, it is essential to first estimate the actual magnitude of a heaviest group of axles or wheel loads, determine the flexural stresses developed due to these wheel loads, and estimate the number of repetition of each load group to use road during the design life. Also, repeated application of a high magnitude of stresses are to cause failures due to the fatigue in cement concrete pavement structures. We will stop here and continue in next class. Thank you.